Now we're going to look at our compound angles for cosine. The National 5 Essential Skills, again are Pythagoras and SOHCAHTOA. So we also have addition formulae for cosine. So cos of A plus B is cos A cos B but minus sin A sin B. So the sign changes from inside the bracket to outside the bracket, so please be aware of that. And cos of A minus B is cos A cos B plus sin A sin B. So be very careful with your sign for cosine. Example 1. Find the exact value of cos of x plus 60 degrees. So first of all, doing an expansion, it will be cos x cos 60, but minus sin x sin 60. So be very careful that you copy the expansion correctly from your formula sheet. So it's always angle A, then angle B, angle A, then angle B. Using our exact value for cos and sin of 60, so cos of 60 is 1 over 2. So we have cos x times 1 over 2, and that will be minus sin x times sin of 60, and sin of 60 is root 3 over 2. Again, just to tidy this up, we'll bring the fractions to the front, and the final answer is a half cos x minus root 3 over 2 sin x. Example 2. Find the exact value of cos of x minus 45 degrees. Again, please double check the formulae when copying it down. So cos of x minus 45 is going to be cos x cos 45, but then plus sin x sin 45. And from there, in our exact value triangle, we can see that both cos and sin of 45 degrees is 1 over root 2. So we get cos x times 1 over root 2 plus sin x times 1 over root 2. We can take 1 over root 2 out as a common factor, and we're left with 1 over root 2 bracket cos x plus sin x. Example 3. Sin A is 4/5 and sin B is 3/5. We have to show that cos of A minus B is 24 over 25. So first of all, we need to pick the correct compound angle expansion. So cos of A minus B is equal to cos A cos B plus sin A sin B. Remember to carefully copy this from your formula sheet. Having a look at the question, we only have the exact values for sin A and sin B. Therefore, we will need to draw right angle triangles to obtain the exact values for cos A and cos B. So if we draw our first triangle with A, sin A is 4 over 5, so opposite is 4, hypotenuse is 5, and this would be a 3, 4, 5 Pythagorean triple triangle that we have there. Our second triangle with angle B has an opposite of 3, hypotenuse of 5, and the missing side will then be 4. So from this, we can see that cos of A is 3/5 and cos of B is 4/5. From there, we put this into our expansion. So cos A times cos B is going to be 3/5 times 4/5. And we're going to add on sin A times sin B, which is 4/5 times 3/5. Multiplying the fractions together, we'll have 12 over 25 plus 12 over 25, which gives a final answer of 24 over 25, as required. Now try these examples for yourself. Please pause the video. The answer to the first solution question is a half cos x minus root 3 over 2 sin x. The second question there is just a proof. If you have a difficulty proving that cos of x plus pi over 2 is equal to negative sin x, please ask your teacher tomorrow in class. So what have we learned today? We've learned how to solve problems with compound angles. Again, it is important that we choose the appropriate compound angle expansion, and very important that we copy the expansion correctly for the formula sheet. We may need to use exact value triangles to simplify the expansion, or we may need to use Pythagoras or SOHCAHTOA to help find missing terms in the expansion.